All right, Algebra 1, we're going to talk about the graphs of quadratics now, right? We've been doing a lot with this x squared thing going on. We're factoring. We actually got to the point where we factored to solve. We're doing the quadratic formula, but what does that answer really mean? And to see that, what we're going to have to do is actually graph what's called a parabola, right? We're dealing with quadratics. We graph it. It's called a parabola, all right? Linear equations created a line. That was really easy to put together. Now we have this kind of weird thing, right? Quadratics and parabolas. All right, so that's what we have. So let's take a look at them first. And I circled that ax squared because that means we're going to end up with a parabola. It doesn't matter if I have bx, right, a linear term or not. If I have x squared, I'm going to end up with one of these u shapes, a parabola. So here's what it looks like. We have a u shape. It could go up. And if it opens up, notice the top goes on forever. So that's pretty cool. But it only has a bottom, a minimum value. Okay. And this minimum value is called a vertex. Okay, we know that it's going to open up because the a value is positive, right? This a is greater than 0. That's code for positive. And if a is less than 0, that's code for negative, right? We're not trying to be sneaky. We're saying greater than 0, less than 0. It just covers it without having to put too much vocabulary in there. And it's really easy to remember, right? Positive people do what? They smile. And negative people, they frown. They're always frowny. They're like Eeyore. All right. Now notice here, my vertex this time when it opens down, that's the maximum value instead of a minimum because it goes down forever. So we can't tell where the bottom is. It's at negative infinity, wherever that is, and it keeps going. But when we talk about a vertex, it could be the top or the bottom based on what's going on. Right down the middle, right? I could take and fold these points over and they would end up on the other one. That's because they are symmetric. So we have a vertical line, x equals, right? Vertical lines. Remember we talked about vux, vertical line, undefined slope, x equals that very middle, okay? And that's going to be the axis of symmetry. Okay? And that's always going to be the same as the middle of your vertex. So let's take a look at that. Let's just identify it. So how do I get to this point right here? So start off with some multiple guess. Choice, multiple choice. Okay, so we're going to go negative 2, and then down 3. So I need to match that one. All right, so all of you that believe in C is always the answer, this time you were right. How about that? And we'll fill this bubble in completely. Don't make any stray marks. If you make any stray marks, you want to make sure you erase. No, this isn't a standardized test. We don't have to do that right now. All right, so for this one, this thing opens up, right? It opens up. So this vertex here, so I'm going to label this point as V for vertex. That's the lowest point that I see here. That makes it a minimum, okay? So I'm going to tie that vocab together. All right, not too bad yet, right? What's the vertex of the graph? Is it a minimum or a maximum? All right, so the first thing I'm going to do is just find out where it is. So this is 0. So the vertex is 0, and we went up 2. And that's the very bottom of this thing. So that's a minimum value. So that's the minimum. This one here, 1, 2, 3. So this is vertex is at 0, 3. And this time that's the very, very tippy top. So that's the maximum value, right? That's the highest Y value that we'll ever get out of this. Graph it. Whoa. This is, wow. What are we doing? We got, right away, now we have to graph it? I just started learning what's going on here. What's the domain and the range? Wow, there's a lot of questions here. Graph it. Let's see. Let's plug in maybe -1, 0, and 1. Right. I know it's a U shape, but I don't really know too much about it yet. So let's just do this. All right, -1 squared is 1. 1 times -3, that equals -3. -3 is 0 squared. So 0 squared is 0 times -3 is 0. And you know what's going to happen if I square 1, I get 1, so I get -3 again. That's enough for a graph for this type of graph. So all I want to do is identify what happened here. So 0, 0, -1, -3, 1, -3. Hey, that's what it looks like right there. All right, so I know the vertex, right? It's already written here, so I'm not going to rewrite it. This is my vertex. It's the highest point, so that's a maximum value. The domain. Now, it's going to continue left and right forever. So I'm going to use my symbol for all real numbers. And the range, it only goes down, right? So y is less than or equal to, that y value right here is 0, right? So it goes down. Okay, so we talked this year a lot about domain and range, mix that in there with some different functions. But now we're really get into it. All right, we're gonna make a table of values and graph this one here, right? So what happened here? This one was upside down, right? Because this our a value was -3. So since it's negative, it should open down, and then we made that table. You know, the other thing we should probably point out here to make this a little bit easier, notice what happens is I went down 1, 2, 3 over 1. So for the first point away, just for the first one, it kind of works like slope, even though I'm not making a line. All right, so I hesitate to say that at all. So we call that a graphing pattern. So what I'd like to do is understand what happens here with this table. -1, that's going to give me 1/3. 0 is going to give me 0. I'll write it here again in case you need to see it. Right, 0 squared is 0 times 1/3. And what's going to happen with 1 squared? We're going to get 1/3. Okay, so I can still make this table, and that's always a good idea. 0, 0, 1, 1, 1. So at -1, I'm at 1/3, and at +1, I'm at 1/3. Wow, this one's really, that's kind of crazy, right? So it kind of looks like the other one. It kind of looks like the normal one, but it looks like somebody like sat on it. It's all squished and spread out stuff. It's like if you brought your peanut butter and jelly sandwich to class and sat on it, it's squished. All right, domain, all real numbers, still okay, because left and right. This one you see a little bit more obvious that it's going to go left and right forever. The range, this time y is going up greater than or equal to, but it stops and it sits down on that 0. So we have those things as well. Right, so that seems weird. So when I multiplied by the negative, it made it upside down. So I'm not worried about that. But it was multiplied by 3. Like this one got really tall, right? Even though it's upside down. And when I multiplied by 1/3, it got really wide. Okay, so as I look at these, right, I want to identify which one's the widest. Okay, so widest is number 1. So that's at 1/4. So that's number 1. Okay, 1/4, because that makes it really wide. And this one's 1, and this one's -4. So I'm really only focused on the 4 part, right? For how wide it is. So I'm going to go with 2 over here because this 4, that looks really tall. Even though it's upside down, it looks really tall. It's been stretched out. Vertically stretched is what we call that. So without a graph, can we put these in order? So widest to narrowest. So what you're really thinking is take out the negatives. We're thinking about least to greatest. Least to greatest. So that means 1/3 is the least, 1 is next, and then 3 is the greatest number out of those. Remember, the negative just turns it upside down, so that has nothing to do with how wide it's going to be. It's just about the orientation of it. All right, so in our next one, let's see here. We want to graph the original, right? So x squared, -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So let's get this one. I'll make this one all green. So that's pretty cool. And then -1, 1, 1, 1, and 2, 4, and -2, 4. So I have this one. Here's our original parabola. Right, we got a vertex right here, 0, 0. Get a lot of cool stuff going on there. All right, let's take the next one. Wait, so it's the same thing, but then I do -3, right? So notice what happened is I can plug all this in. I get 4, and then -3 gives me 1. So if I plug in -1, I get 1. -3 is -2. If I plug in 0, -3 is 3. So 1's going to give me -2, and 4. Right, so I'm going to plug in 2. 2 squared is 4. -3 gives me 1. So this is what we're looking at. So 0, -3. 1, -2, -1, -2, and 2 lands at 1. So really what happened is I took all the points that I had, and they each went down 3 to make this a new parabola. So that tells me that when I want to look at this, I can actually tell before I make a table or graph it, this thing has been translated down 3 units. Because that's what we're going to get into as we do a little bit more with these is how to translate them. Now that you know what it is and what it looks like. Ooh, I missed a point there. That's all right. Just kind of sketch a little bit more. So whether it's the graph, I want you to take the graph and move it up or down like that, or if I want you to make a table out of it, we can do that. Okay, so let's take a look at these. Ooh, yellow was a bad choice. Sorry about that. So x squared plus 5. If I add 5, that's up 5, right? Minus 1. Where's it going to go? It's going to go down 1 unit. What about x squared plus 2? Well, we know that's up 2. Come on now. This one's also up 2. Why did I do 2 of these? Oh, there's a negative on here. It's a negative. What's that mean? It means it's going to be turned upside down, right? All right, so technically what we call that is the x-axis reflection. Okay, so we're going to use common terms like it's upside down. We flipped it over, anything like that. Okay, academic term is we call it an x-axis reflection. Remember, this one here is the x-axis. Okay, so if I turn it upside down, it's been flipped over that x-axis. So we call it an x-axis reflection. All right, what do we got here? Let's get to an acorn drops from a tree branch. Oh, a bunch of squirrel problems here. I don't know what's going on. So here's the equation. What's it say? What's the graph at the time it hits the ground? Okay, so it's about time, right? So time 0. So what I might do is just make a quick little table here. Time 0. So I get negative 16 time. I don't need a t anymore. I know it's time 0 squared plus 70. All right, so 0 squared. So this is 70. So at 0 seconds, we have a very happy acorn. And here it is. Okay, then what's going to happen is 1 second into this whole thing. So this is going to give me the height. So I get negative 16, 1 squared plus 70. So 1 squared is 1. So I got negative 16 plus 70. So I got to take 16 away from 70. That's what, 54. So 1 second, we're at 54 feet. All right, so 154. 2 seconds. How about 2 seconds? Negative 16, 2 squared plus 70. All right, so that's 4 times negative 16. So it's negative 64 plus 70. Oh, man. That was a huge drop between 1 and 2 seconds, right? Because now this acorn is 6 feet away from the ground. So we could plug in 3, right? Let's do 3 squared. That's 9 times 16. Okay, so we get negative 16, 3 squared plus 70. So this is going to be 9. So I get negative 144 plus 70. That's negative 74 feet. So the height is negative. So at this point, the acorn has gone into the ground, 74 feet into the ground. I think it's probably just going to bounce, right? But we get the idea that it's going to hit the ground between 2 and 3 seconds, and it's going to be a whole lot closer to that 2 seconds than it is to the 3, just based on what's happening here. Okay, so we got something like this going on. And also just looking at the trajectory of our graph, what happens? Now, here's the thing is you guys actually know how to solve this, right? If something is on the ground, its height, right? Its height now is 0. So 0 equals negative 16 t squared plus 70. You'll subtract the 70. Negative 70 equals negative 16 t squared. Let's divide out that negative 16. So t squared equals, what do we got? 70 divided by 16. And that's going to be a mess, right? 4.375. And how do we get rid of squares? We take the square root of it. Okay, so let's take the square root of that. And guess what? It's 2.0916 seconds. Well, that's pretty doggone close to what we thought. We thought it was really close to 2. Okay, so those are the ideas that we're working with today. That's what a parabola looks like. This is where it gets used. And thank goodness we have some quadratics. So there's a little vocabulary review here if you're in my class. You want to make sure you plot in and point out all the obvious things there. And then a couple practice. These go along with exactly what we have done. Okay, that is part of today's work. So give those a whirl and we'll work on this some more in class.